section 14.3 ellipses. So an ellipse is, well, if I take 2 points in the plane, we'll call each of these points a focus. So I have here 2 foci. Then the locus of all points whose sum of distances to each of their foci are the same is called an ellipse. And so if I take any point on the plane, on the ellipse, say over here somewhere, and I take the sum of their distances, and I take another point on the ellipse, say this point, and I look here at the sum of these distances, then I should have that these two sums are the same. So if you take any 2 points on an ellipse, then the sum of the distances to the foci will always be the same distance. Okay, so let me do an ellipse again. Yeah, close enough. So suppose I have 2 foci. Then the line passing through the foci is called the focal axis or the major axis. The midpoint between the foci is called the center. The line perpendicular to the major axis passing through the center is called the minor axis. And each of these points here are called vertices. So this is a vertex. So each of these are vertices. So you have these 4 vertices. You have a major axis, which is the axis that contains your foci, and you have a minor axis. It actually turns out that the major axis will always be longer than the minor axis. So this major diameter here is always larger than the minor diameter. So suppose okay, so suppose that we have some ellipse, and I guess what I'll do is I'll try to find the equation of my ellipse. And so let's do this. Suppose that so I'll determine equation of ellipse. And this will be with center being the origin. Okay, and foci will be along the x-axis. And so let's say that it's at plus or minus c, 0. Okay. Where in this case, I'll assume that c's greater than 0. Okay. So let's do that. And let me determine the equation in this particular case. And so I have here an ellipse with center at the origin. And so the center here is at the origin. And here I have some foci, minus C0 and C0. Okay. So let me suppose that the distance here, so suppose I have some point HK. Let's try to determine the equation of that. Well, so I'm going to do this distance here. Between these two. Okay, so well, first off, maybe I'll figure out some values here. Let this point here, let's call it A, 0. Now, and so that's one of my vertices. Now, since the center is the midpoint between the two foci, well, it's also the midpoint between the two vertices, so the other one will be minus A, 0. And so let's call this point up here 0b. So again, the fact that the sum of the distances to the two foci will be the same, then this point must be antipodal to this other point, so it must be at 0, negative b. And let's try to use that to find the equation for this. Now, I have here that, let's look at each of these distances. So maybe I'll call this first distance, I don't know, D1, and this distance D2. Okay? And so D1 is going to equal the square root of, well, let's see. This will be, again, the difference of their x coordinates, x minus a negative c squared, plus the difference in their y coordinates, y minus 0 squared. And let's figure out d2. And so again, it's going to be the difference in their x coordinates, x minus c squared, the difference in their plus the difference in their y coordinates squared. Okay, good. Now I must have the sum of these two must be the same for any point. As a matter of fact, let's do this point. Okay, and so the distance here is just going to be, well, from here, from this point here, this foci F1 to, so note, the distance from F1 to the point A0 to 0 to the point 0, 1. Well, that's going to be C plus another A. And the distance from F2 to 0, 1 to A0. So this distance here will be, well, it's just going to be A minus your C. So thus, if you add these two distances together, so the sum of the distances is, well, C plus A minus C, which is 2A. Since for any point along this ellipse, the sum of the distances must be the same, then I must have that the square root of x plus c squared plus, well, y minus 0 is just y squared, plus square root of x minus c squared plus y minus 0, y squared, is 2a. Let me give a little bit more room here. So this is equal to 2a. Okay, so let me try to solve this. And so this is a, well, a radical equation. So let me just subtract radical x, oops. And so, oh, I gotta get rid of this still, because it's the wrong color. Okay, so this is subtract radical x minus c squared plus y squared from both sides of my equation. So if I do that, I get the square root of x plus c squared plus y squared is equal to 2a minus radical x minus c squared plus y squared. So now let's try to solve this radical equation. So let me square both sides of my equation. So let me square it. So the square gets rid of the square root. So I get x plus c squared plus y squared is equal to, well, it's a perfect square trinomial. So I get 4a squared minus 4a rad x minus c squared plus y squared plus x minus c squared plus y squared. So let's multiply this out. And so I get x squared plus 2cx plus y squared equals 4a squared minus 4a rad x minus c squared plus y squared plus x squared minus 2 cx plus c squared. Oh, what happened to plus c squared? Oh man. X squared minus 2cx plus c squared. Well, this is going to be tight. Okay, wait 1 second. It's too tight. So this is equal to 4a squared minus 4a rad x minus c squared plus y squared plus, so foiling that out, you get x squared minus 2cx plus c squared plus y squared. Okay, so now let's do some subtractions. Minus x squared minus x squared minus 2cx, no, plus 2cx minus c squared minus c squared minus y squared minus y squared. So almost everything cancels. And so almost everything cancels, but not quite. The two cx's don't cancel. Oh, and subtract 4a squared. And so let's do that. And so a squares cancel. 2cx plus 2cx is 4cx. C squares cancel, y squares cancel, minus 4a squared is equal to a squares, 4a squares cancel, negative 4a rad x minus c squared plus y squared. X squares cancel, 2cx's cancel, c squares cancel, y squares cancel. Okay, so far so good. So now, let's divide by 4. Negative 4. And so I get negative, that makes it positive a squared minus cx is equal to a rad x minus c squared plus y squared. Let me square both sides of my equation. And so I get a to the 4 minus 2a squared cx plus c squared x squared is equal to a squared times, well, let's get rid of the square. Actually, let me multiply out what's inside. So I get x squared minus 2cx plus c squared plus y squared. And let me multiply the a squared inside the parentheses. And so I get a to the 4 minus 2a squared cx plus c squared x squared equals a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared. And so I get that, subtracting So let's bring that over. Okay, so now let's do this. So adding 2a squared cx, 2a squared cx to both sides, subtracting cx squared, c squared x squared from both sides. I get the following. I get a to the fourth is equal to a squared x squared minus c squared x squared. These cancel. Plus a squared c squared plus a squared y squared. Okay. So let me subtract a squared c squared from both sides. And so I have a to the, well, maybe I'll write this first. And so let's do the a squared x squared first, and let me factor out the x squared. So I have a squared minus c squared x squared plus a squared y squared equals a to the fourth minus a squared c squared. Let's factor out a squared. So I have a squared minus c squared x squared plus a squared y squared equals a squared times a squared minus c squared. Divide both sides of my equation by a squared minus c squared, a squared minus c squared, a squared minus c squared. And so, of course, assuming that a is not equal to c, meaning that if a and c were the same, then we would have a, I guess, a degenerate sort of circle, and that we don't want that. And so everything cancels here. So I just have x squared over a squared plus y squared over a squared minus c squared is equal to 1. And what you notice here is that b is just b squared is equal to a squared minus c squared. Okay? And so, or usually we write it the other way. We usually do the following. We usually subtract b squared and add c squared to both sides to get the equation in the form c squared equals a squared minus b squared. Okay, so now that's of course assuming here that a is larger than b. So the equation, so I get from here finally that the equation for my ellipse is just x squared over a squared plus y squared over b squared equals 1, where c squared is a squared minus b squared in absolute value. And so that is the equation of an ellipse centered at the origin. Now, of course, we could always assume that instead I shifted it, and so this is, suppose now the center is at hk, then the equation would be x minus h squared over a squared plus y minus k squared over b squared is 1, where again I have c squared is a squared minus b squared, doesn't really matter, a squared minus b squared in absolute value. And that is the equation of my ellipse. Okay, so examples of where you would see these. And so suppose that you have, I don't know, let's do the sun again. And suppose you have something in orbit around it, like the Earth. So you have the Earth here and the sun here. Then the Earth will go around the sun in an elliptical pattern, and the sun will be centered at one of the foci. So it turns out that the center of the sun actually is at the foci, one of the foci, for which the Earth travels in the elliptical pattern. Another example would be, suppose that you go to, let's take a little point here, what's called a whisper room. So this is some ellipsoid. And so if you go to things like the Capitol building, or say if you go to Exposition Park at the Museum of Natural Sciences, and they have what are called whisper rooms. And so if you stand at a point that is marked in the whisper room, and your friend stands at the other mark in your whisper room. These are located actually at the foci for this ellipse. And it turns out that if you whisper something, so you say something really very, very lightly, then the other person will be able to hear it. So you say something in a whisper, and the other person's able to hear it. And whereas even people really close to them aren't able to hear it, but if you stand at the foci, you can hear it from, across a very large space. And that's called a whisper room. Another application of ellipses is, suppose I have a kidney stone, so really big kidney stone there, and I go to the doctor, and he gives me a treatment which is non-surgical in nature. What he'll do is he will have you sit in this gigantic bath of water. So you sit in a gigantic bath of water, and you sit such that your kidney stone is located at one of the foci for this elliptical bath. They then vibrate very rapidly the edges of this bath, and every sound wave comes and strikes your kidney stone, and it pulverizes it. And so that's one way of pulverizing your kidney stone, is by just putting you in a bath of water, vibrating the sides of the bath very rapidly, and having the object located at the foci be destroyed by all of these waves coming in to destroy it. Okay. Let me do oh, and I guess you should notice that if you look at this point, then this distance seems, well, then you get that b squared is just a squared minus c squared. Let me do some examples. On page 600, let me do problem number 6. X squared over 4 plus y squared over 16 is equal to 1. In exercises 1 through 14, graph the ellipse, give the lengths of the major and minor axes. Okay, so first off, I notice that the center of this ellipse is at the origin. And that A is equal to 2, B is equal to 4. The square root of 4 is 2. The square root of 16 is 4. And C, well, you don't really need that, but 16 minus 4 is 12, so it's the square root of 12, which is 2 rad 3. Okay, so let's do this. So A is 2, so 1, 2, 1, 2. B is 4, 1, 2, 3, 4, 1, 2, 3, 4. Actually, I think I'm off by a little bit here. And so 1, 2, 1, 2. Okay, so let me draw my bounding rectangle. So this is actually called a bounding rectangle. Your ellipse will be completely contained within your bounding rectangle. Your vertices are located at these points. Your center here. And let's see if I can draw my ellipse. Good enough. And that is my ellipse. And so here are my vertices. So the center is at 0, 0. Vertices at 2, 0, negative 2, 0, 0, 4, 0, negative 4. And then the, so 2 radicals, so it's around here. Then the foci are located at 0, 2 rad 3, and at 0, negative 2 rad 3. And that is my ellipse. Let me do problem number 12. Two x squared plus 9y squared is 18. Divide both sides of my equation by 18. And so I get x squared over 9 plus y squared over 2 is equal to 1. And so, therefore, the center of my ellipse is at 0, 0. A is the square root of 9, 3. So I always take A to be the object under X. So A is equal to 3. And B is equal to the square root of what is under the Y. And so, well, C is equal to, well, let's take the larger number. 9, subtract from it the smaller, 2. 9 minus 2 is 7. And so C is the square root of 7. And so let's draw this. In this case, I guess I'm not going to draw the bounding rectangle. I usually actually don't draw bounding rectangles for ellipses, so I'm not going to draw it. And so A is 3. 1, 2, 3, 1, 2, 3. And the square root of 2 is somewhere around here. And notice I just drew the bounding rectangle. Okay, who cares? And so here are my vertices. Here's my center. And let's see if I can draw my ellipse. And my foci are at radical 7. So somewhere around here. So here are my foci. Here are my center. And here are the vertices. Okay. Let me do problem number 28. Oh, actually, I did 12. Let me do problem number 26. Let me do problem 26. 12. X plus 2 squared. 3. Y plus 1 squared is equal to 12. In exercises 15 through 26, find the center, HK, length of the axes, and graph each of the given ellipses. Okay, so let me do that. So let me divide both sides of my equation by 12. And so I have here x plus 2 squared plus over 1 plus y plus 1 squared over 4 is equal to 1. And so the center of my ellipse is -2, -1. A, square root of 1 is 1. B, square root of 4 is 2. C, 4 minus 1 is 3. So C is the square root of 3. Let me draw this ellipse. X, Y. So the center is at -2, -1. I go 1 in the X, and I go 2 in the Y. So I'll go 2 in the Y, and 1 in the X. And so here are my 4 vertices. The vertices are located at -2 plus or minus 1, -1, negative 2, negative 1, plus or minus 2. So you add and subtract your a to the x. You add and subtract the b to the y. The foci, well, the center, of course, well, I have the center. The foci are located at, well, 2 is bigger than 1, so therefore the foci will be along the y-axis, and so, or parallel to y-axis, and so this will be at the point negative 2, negative 1, plus or minus c, which is radical 3. And so let's do that. So this is somewhere around here. So that's the center. Those are my vertices. And there are the foci. So let's try to draw this if I can, as best I can. And those, and that is my ellipse. Not a great ellipse, but it's at least a semi-ellipse. Let me do problem number, so that was what, 26? Let me do problem number 30. 28 doesn't look bad. 28. Let me do problem 28. X squared plus 4y squared minus 2x plus 16y plus 13 equals 0. Group the x's together. So x squared minus 2x plus 4y squared plus 16y equals, well, bring the 13 to the other side of my equation, negative 13. So let's group these x's and y's together. And so I have here x squared minus 2x plus, factor out of 4, 4y squared plus 4y equals negative 13. Complete the square. Negative 2 divided by 2, negative 1 squared is 1. Add 1 to both sides of your equation. 4 divided by 2 is 2. 2 squared is 4. So let's add 4 to both sides of my equation. Shoot. Okay. So let's add 4 to both sides of my equation. And so add 1. Four times 4 is 16, so let's add 16. And so what's in the parentheses is a perfect square trinomial. And so I can write this as x plus 1, x minus 1, quantity squared plus 4, y plus 2, quantity squared equals negative 13 plus 1 plus 16 is equal to 4. Let me divide both sides of my equation by 4. And so I have here x minus 1 squared plus y plus 2 squared is equal to 1. Okay, so that's the equation of my ellipse. And so in this particular case, the center is at 1, -2. A is equal to square root of 4. And maybe I'll write this over 1. The square root of 4 is 2. B is equal to square root of 1 is 1. C is equal to 4 minus 1 is 3. So the square root of 3. And so let's figure out the vertices. And so the vertices are located at 1 plus or minus a, 2, -2. 1 comma -2 plus or minus a, 1. The foci are located at, since 2 is bigger than 1, then I'm going to add radical and subtract radical 3 from I will add, okay, sorry about that. I will add and subtract radical 3 to the x-coordinate of the center. And so I have the following ellipse. So x is 1, -2. That's my center. I will go 2 in the x. I will go 1 in the y. And so my ellipse will look something like this. Good enough. I'm not really very good drawing that. And the foci will be along the x. So 1 plus, so radical 3 is almost 2. So it's, here are my foci. So here are the vertices, the center, and the foci, given by, obviously, these coordinates. Let me do problem number 36. Three x squared plus 5y squared plus 12x minus 10y equals -2. So let's group the x's together. 3x squared plus 12x plus 5y squared minus 10y equals -2. Factor out the 3. 3x squared plus 4x. Factor out the 5. Y squared minus 2y equals -2. And so 4 divided by 2 is 2. Squared is 4. Times 3 is 12. -2 divided by 2 is -1. Squared is 1. Times 5 is 5. And so I have 3x plus 2 quantity squared plus 5 y minus 1 quantity squared is equal to 15. Divide both sides of my equation by 15. And so I have x plus 2 squared over 5, y minus 1 squared over 3 is equal to 1. And so in this case, the center is at -2, 1, a radical 5, b radical 3, 5 minus 3, 2, c is equal to radical 2. And so the vertices are at a -2 plus or minus rad 5, 1. Negative 2, comma 1, plus or minus rad 3. And the foci are at, let's see, A is bigger than B, and so negative 2 plus or minus rad 2, 1. And so those are the vertices and foci. The center is at negative 2, positive 1. I go radical 5 in the x direction. Okay. I go radical 3 in the y direction. About here, and radical 3 about here. Okay, so my ellipse should look something like, actually, that's not too horribly bad, at least all but this last piece that I drew. And the foci, so axis is bigger, and so it's going to be radical 2, so that's 3, so it's about here. And it's going to be about here. So that's these are the vertices. Here are the foci, and here's the center of my ellipse. Okay, let me do problem number 50. In exercises 49 through 59, find the equation of ellipse given the foci and ellipses and vertices. So the two foci are at plus or minus 3, 0. And the vertices, and two of the vertices, are at plus or minus 5, 0. Okay, so in this case, I have I'll just draw just a sketch to give me some little idea. So the vertices are at 5, and the foci is also along the x-axis, so this is a major axis. So somehow you look something like, I don't know, like this. So this is 5, 5, and then you have some foci at negative 3, 3. Okay. And I don't know what B is, but I do know that the center is at the origin. So therefore, the equation of my ellipse, and this is because, well, the center will be at the midpoint between the two foci. It'll be at the midpoint between the vertices. And so, and I never gave the lengths of the major and minor axes, did I? Oh, I forgot about that. The length of the axes. Forgot about that. I'll have to do that during class, I guess, or go back and do those. I forgot about that. Okay, problem 50. And so the equation is x squared over a squared plus y squared over b squared is 1. In this case, a is 5. B, I don't know what B is, but I do know what C is. So A is 5, B is 3, C is equal to 25 minus 9, 16, 4. So C is 4. Okay. Wait, I don't know what B is. I should have written it the other way around. Okay, let's try this again. A is 5. I do not know B. C is equal to 3. But I know that A squared minus B squared is C squared, because I know that the major axis is along the x-axis. So A is bigger than B. So I don't need absolute value because I know that A is larger than B. And so 5 squared minus B squared is C squared. 25 minus B squared is 9. Subtract 9. Subtract 9. Add B squared to both sides of your equation. And so B squared is equal to 16. So therefore the equation is x squared over 25 plus y squared over 16 is 1. And that is the equation of your ellipse. Let me do problem number 54. The foci are at 0, plus or minus 1, and the two vertices are, and two of the vertices are 0, plus or minus 4. So therefore, the center is at the origin because it's at the midpoint between these foci. And so the equation is x squared over a squared plus y squared over b squared is 1. In this case, I don't know a, but b, the foci are at plus or minus 4, so it's 4. C, well, the foci are at plus or minus 1, so C is 1. I have that b squared minus a squared is c squared. And so 16, well, 4 squared minus a squared equals 1 squared. So 16 minus a squared is 1. Subtract 16 from both sides. Negative a squared is negative 15. So a squared is equal to 15. Therefore, the equation of your ellipse is x squared over a squared plus y squared over 16 equals 1. And that is the equation of your ellipse. Let me do problem number 56. The foci are at 0, plus or minus 3, and the length of the major axis is 10. Oh, so that reminds me about I forgot about lengths of axes. Let's see, which one did they ask for? Lengths of the major axis in problems 1 through 14. So let me go back to 1 through 14. It'll only take a second to figure out the lengths of the major axes and minor axes. And so 1 through 14. So the length of the major axis Well, I'll start with the axis, the length of the minor axis. Well, you go from -2 to +2, so that's 4. The length of the major axis, you go from 4 to -4, so that's 8. Okay, and that's so problem 12. So the length here of the major axis, well, we go here from -3 to +3, so it's 6. The length of the minor axis, we go from radical 2 to negative radical 2, so 2 rad 2. Okay. On 26, we didn't need 2. Up to 36, we didn't need 2. We didn't need, oh. And so on problem number, oh, I didn't do any of the problems 38 through that, so 28. So I did 28, didn't need that. 36, didn't need it. Oh, I should have done another problem. I'll have to interject another problem here because I skipped. No, somehow I skipped 37 through 48. I'll have to do one of those. Okay, so 37. Aha. Okay, so let me do that. 37 through 48. Okay, so from 50, okay, so let me move this. Let me move this. Okay. Okay. So we did problem 36. Okay, so let's do problem number 38. I missed those. In exercises 37 through 40, give the standard form of the equation of an ellipse with center 0, 0, with the given x and y intercepts. So we're given the following intercepts. 1, 0, -1, 0, so plus or minus 1, 0. And 0, 4, 0, -4, so 0 plus or minus 4. Okay, so if I do that, and so I have here the intercepts are plus or minus 1 and 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and so here's my ellipse. So there's my ellipse. And so the ellipse will have the form x squared over a squared plus y squared over b squared is 1 because the center is at the origin, because it tells us the center is at the origin. And so a in this case, well, it's got to be 1. And b in this case has got to equal 4. So x squared over 1 squared plus y squared over 4 squared, 16, equals 1. And that is the equation of your ellipse. Let me do problem number 42. X squared over 16, y squared over 4 equals 1. And so in exercises 41 through 48, c squared equals a squared minus b squared, or c squared equals b squared minus a squared. Name the foci of the ellipse with the given equation. Okay, so let's do that. And so I have that a is equal to 4, square root of 16 is 4. B is equal to, square root of 4 is 2. C is equal to, well, 16 minus 4. I take the larger number, 16, subtract from 4, 12. I can write 12 as 4 times 3. Square root of 4 is 2. And so, let me determine my foci. Since the center is at the origin, then the foci are located at, since 4 is bigger than 2, plus or minus 2 rad 3, 0. Let me do problem number 48. 16 x squared plus 25 y squared equals 400. Divide both sides of my equation by 400. So, x squared over 25 plus y squared over 16 is equal to 1. And so, the center is at the origin. A is equal to 5. B is equal to 4. Square root of 25 is 5. Square root of 16 is 4. 25 minus 16 is 9. The square root of 9 is 3. And so the foci are located at, so I can actually make a little bit more room here. Let me bring everything down by a little. So the foci are located at plus or minus, 5 is bigger than 4, so plus or minus 3, 0. And those are your foci. And so let me finish off whatever problem I was doing before. Problem number 56. Okay, so let's see if I can remember this. So, equation of ellipse with the given foci and vertices. And so the foci are at 0 plus or minus 3 and the major axis. So my foci are along the y-axis. So here's your foci. So therefore your ellipse has got to be in that direction. Not a very good ellipse. It's just an ellipse. Therefore the center must be at the midpoint, which actually turns out to be the origin. The major axis, therefore, must be in the y direction, which in this case has a length of 10. And so, since your center is at the midpoint between your two vertices, then that says that I don't know A, but I know that B is equal to, well, the distance here from one vertex to the other is 10. Therefore, the halfway is 5. And, well, the midpoint between the two vertices is the center. Therefore, the vertex is located at 0, 5. So B is 5. And C, well, the foci are located at plus or minus 3. And so let's figure out what a is. Well, b squared minus a squared is c squared. I know that b is larger than a because the focal axis, the major axis, is along the y direction. 5 squared is 25. C squared, 3 squared. 25 minus a squared is 9. Subtract 9 from both sides. Add a squared. And so I get that a squared is 16. And so the equation of my ellipse, x squared over a squared plus y squared over b squared equaling 1 is, well, a squared is 16. B is 25. Well, b is 5, so b squared is 25. And so that is the equation of my ellipse. And so that finishes off section 14.3. And so that finishes off what I wanted to talk about.